प्रीवियस लेक्चर में हमने सफिशिएंट कंडीशन करा दी थी ना फॉर फंक्शन टू बी एनालिटिक। हेलो,
यस मैम।
क्या सफिशिएंट कंडीशन कंप्लीट हो गई थी ना फंक्शन टू बी एनालिटिक के?
यस मैम।
So today I will start with polar form of Cauchy-Riemann equation. Polar form of the Cauchy-Riemann equation, in short, CR equation. Suppose that we have an analytic function fz whose real and imaginary parts are u and v. So when z is represented in this form, polar form, r e I theta, where x is r cos theta and y is r sin theta, and this theta can also be written as tan inverse y by x, and r is under root x square plus y square. Okay, so you know that u and v are the real valued function of x and y. So if we are substituting this x in form of r cos theta and y as a r sin theta, so we can say that here u and v are also the function of r and theta. So we can say here that this u must be function of r and theta. So in that case, polar form of Cauchy-Riemann equation will be, you know that CR equation in Cartesian form is partial derivative of u with respect to x is equal to partial derivative of y with respect to y, and del u by del y is equal to del v by del x. You can also write this equation in polar form, which will be del u by del r is equal to 1 by r del v by del theta, and del v by del r is equal to minus of 1 by r del u by del theta. Yes, you can easily prove it because you can write here del u by del r या del u by del x को आप लिख सकते हो in terms of r and theta by using the chain rule. So इसके लिए you can use here del u by del x into del x by del r. Yes, del r plus del u by del y as del v by del r. And del u by theta, you can also obtain del u by del theta by writing del u by del x into del x by del theta and del u by del y into del y by del theta. So by using this equation, you can prove this equation, which is the polar form of CR equation. This is the CR equation in polar form. ये काम आप कर सकते हैं. You can verify it. And you know that f dash z is del u by del x I times del v by del x. So you can also find this del u by del s in terms of r and theta. So this must be in polar form will be equal to minus exponential iota into theta, again exponential of minus I theta del u by del r plus I times del v by del r. And this can also be written as 1 by r e minus I theta del v by del theta minus time I del u by del theta. By using the CR equation here, we will get this expression. So this is the derivative of the function in polar form. Okay. So next topic is harmonic function. Harmonic function. So a real valued function phi x comma y of variable x and y has continuous first second order derivative has continuous second order partial derivatives in a domain D, and they also satisfy the Laplace equation which is del u upon del phi, sorry, it will be phi del square f phi upon del x square del square phi upon del y square is 0 in D, in domain D, then is said to be then phi xy then phi xy is said to be harmonic in D. Harmonic in D. Okay, this is the definition of a harmonic function. Here is an important theorem related to analytic function. The statement of theorem is if phi z, its real and imaginary part are u and v, is an analytic function in a domain D. Is a analytic function in a domain D. Then its real and imaginary parts, satisfy Laplace equation. Satisfies the Laplace equation. That is, we have to show that this ux and vs satisfying the Laplace equation means del square u upon del x square plus del square u upon del y square is 0, and also del square v upon del x square plus del square v upon del y square is 0. We have to prove it. Okay, because fz is analytic function, so its real and imaginary parts must satisfy the CR equation, which is the necessary condition for the function to be analytic in domain D. As it is given that fz is equal to u plus iv is analytic in D, so u and v must satisfy the CR equation, which was del u by del x is equal to del v by del y, and del u by del y is equal to minus times del v by del x. Okay, so first of all, we want to show that this u satisfies the Laplace equation. So we will take this equation and differentiate both sides of this equation with respect to x. ये वाली equation लेते हैं. So differentiating this equation both sides with respect to x, we will get del u upon del x square equal to del square v upon del x del y. Okay. Again, differentiating this equation, say that it is equation and this is equation 2. Okay. So again, differentiating partially 2 with respect to y. With respect to, yes, now we are differentiating this equation with respect to y. So we will get del square u upon del y square is equal to minus times del square v del y del x. Say that this is equation 3rd and this one is equation 4. Because u and v are the real and imaginary part of this analytic function. और ऐसा है कि फंक्शन हमारा क्या है, सेकेंड ऑर्डर डेरिवेटिव जो है इसके कंटिन्यूअस होते हैं. सो बाय दिस डेफिनेशन when we are equating these two from this equation number 3rd and 4th, from equation 3rd and 4th, we can say that del square u when we are adding, या ऐसा कर दें, when we are adding equation 3rd and 4th, this will give us del square v upon del x del y plus minus del square v upon del y del x. They must be equal and it will be 0. So we simply get that u is satisfying Laplace equation. In the same manner, we can also show that by using the CR equation, v is also satisfying the Laplace equation by differentiating first equation partially with respect to y, then equation second with respect to x, and then adding that equation, we can show that v is also satisfying the Laplace equation. Okay, so when fz is analytic in a domain D, then its real and imaginary parts are harmonic function. यहाँ से हम बोल सकते हैं कि they are the harmonic function, and vxy is called conjugate harmonic function. Conjugate harmonic function of ux comma y in D. If they are the real and imaginary part of analytic function, so this v is called as conjugate harmonic function of uxy. Okay, so here I am taking a question which is related to this topic. Show that we have a function ux comma y 2x plus y cube minus 3x square y. We have to show that it is harmonic. And find its conjugate harmonic function and find its conjugate harmonic function vx comma y and corresponding analytic function and also corresponding analytic function. अब इसको फाइंड करने के दो तरीके हैं, या तो हम इसको डायरेक्ट जो है CR इक्वेशन की हेल्प से कर लेंगे, या एक और मेथड है उसको हम बाद में डिस्कस करेंगे. तो पहले हम इसको कर लेते हैं कि फर्स्ट वी हैव टू शो दैट इट इज सैटिस्फाइंग द लाप्लास इक्वेशन. ओके, u is given here. So u, partial derivative of u with respect to x one time, it will give us 2 times 6x comma y, and u double dash is equal to minus 6y. Again, we will differentiate this function u partially with respect to y. This will give us 3y square minus 3x square, and u double dash y will give 6y. So ux plus u double yy is 0. So this implies that u is harmonic. Now the next is we have to find the vx, which is the conjugate harmonic function of ux. Okay, So it is conjugate harmonic function. So they will must satisfy the CR equation. So यहाँ से हम ले लेते हैं. So we can write Vy by CR equation. We can write Vy is equal to Ux, which is 2 minus 6xy. Now integrating this function with respect to y. So this will give us V. This will give you V and 2 times y minus 3xy square plus, because we are integrating only with respect to y, so here we are adding a function of x. We are arbitrarily, y is the arbitrary function of this x. Say that it is equation number 1. This is equation number 1. Now again differentiating this equation 1 partially with respect to x. And we are differentiating this partially with respect to x, या कहें हम Vx लिखते हैं. Vx will be minus 3y square phi dash x. Say that it is true. Now you can see that यहाँ से हमारा Vx मिलेगा. That will be Vx will be minus time uy. So we can write the value of Vx here with the help of this uy. This will, we can write, substitute the value of Vx by this method. एक second. Sorry. So Vx will be minus of 3y square plus 3x square minus 3y square plus phi dash x. Okay, both sides we are cancelling this term. We will get phi dash x is equal to 3x square. We get phi dash x is equal to 3x square. I think it was 3x square, yes. So now integrating this function both sides with respect to x, this will give us phi x is equal to x cube and plus constant of integration. Phi x is equal to x cube plus c. Now substituting this value of phi x in equation number 1. What was the equation number 1? It was v2y minus 3x square. 3xy square. 2y, v was 2y minus 3xy square plus.
And please show the previous slide once again.
Yeah. 2y minus 3xy square plus phi x. In place of this phi x, we will substitute the value.
मैम ये यहाँ पे vx जो था वो uy के इक्वल था यहाँ पे.
माइनस टाइम uy.
ओके मैम, ठीक है.
So 3xy square. Now substituting with this value of phi x, it will be x cube plus c. So this is our harmonic conjugate of u. Now we have to also find the analytic function fz whose real and imaginary parts are u and v. So analytic function will be fz u plus iv. Now substituting this value of u and v, u was 2x y cube minus 3x square y plus v was 2y 3x y square plus x cube plus c. This can also be written as 2x प्लस इस टर्म को इसके साथ लिख रहे हैं 2y, यहाँ पे भी छोड़ देते हैं तो इस ओके, देयर इज नो प्रॉब्लम, but we want to write it in form of z, that's why we are collecting the term of x and y. So 2x plus I times 2y and y cube minus plus I x cube and 3x square y minus I 3xy square plus I into c. This I into c can also be replaced by new arbitrary constant c1 if we want. So if we want to take this I out of we want to take common this y term, so this will be x plus iy I into upon I upon I minus times I y cube plus x cube, and this will be plus 3I x square y minus 3x y square. Yes, 3x y square, yes, plus iota c. So 2x plus iy plus I, this can also be written as x cube I into y whole cube 3x square iota y minus plus 3x iy whole square plus iota c. So now we can also write it as fz 2 times x plus iy plus I x plus iy whole cube plus I. So in place of this x plus iy, we can write z. Z I z cube plus, in place of this I, we can also write this c1. So this will be our analytic function corresponding to whose real part is given here. So by if only the real parts of an analytic function is known, so we can also find this function fz. एक ये तरीका है। दूसरा हमारे पास एक तरीका होता है जिसको बोलते हैं हम मिलन-थॉम्पसन मेथड। Milan-Thomson method. So we know that x is, we can write x as z plus z conjugate upon 2, and this y can also be write as z minus z bar divided by 2f. इस तरह से हम यहाँ पे लिख सकते हैं. So we also know that fz is ux comma y plus I v x comma y.
मैम इसको z के फॉर्म में लिखना जरूरी है? fz हमारा जो है 2z
यहाँ पे
प्लस
फाइनली नहीं, हमेशा जरूरी नहीं है. Sometimes in the question they said that evaluate this fz in terms of z, तब जरूरी हो जाता है. अदरवाइज हम वहां भी छोड़ देंगे तो देयर इज नो प्रॉब्लम. ठीक है
मैम, क्योंकि कभी कभी बहुत मुश्किल हो जाएगा उसको, मतलब
हाँ
x प्लस आइटा y लिखना.
हाँ, उसमें प्रॉब्लम हो सकती है, लेकिन जो है अगर नहीं लिखा है तो वहां भी छोड़ देंगे, कोई दिक्कत नहीं है. अदरवाइज इसको यूज कर सकते हैं, इसको सब्स्टिट्यूट कर देंगे. ओके, so first we know that fz is this type and f dash z is ux plus I vx. इस तरह से हम इसको लिख सकते हैं. और vx को by CR equation, because fz is analytic function, तो vx can be write as ux minus I uy if u is given. If u is given, ये vice versa भी हो सकता है कि sometimes we know the imaginary part and we have to evaluate this real part and then we have to calculate this function fz. So f dash z is ux minus I times uy. Okay, u is given here. Okay, u is given here, and uh, in this method we replace y by 0. For suppose that y is 0 here. So in that case, x must be equal to z. Z1 is, sorry, z, because we know that z is x plus iy. So when y is 0, so obviously x will be z. In that case, you know that partial derivative with respect to x, it is again the function of x and y. So when we are in this function, because it is again the function of x and y, या हम इसको इस तरह से लिखें, ux is again the function of x and y, and when we are replacing this y by 0 and x by z, it will be ux z comma 0, and denoting this function by phi 1 z comma 0. Denoting this function, say this is ux की value at that time, we are saying it is phi 1 z comma 0. Again, uy at z comma 0 is denoted by phi 2. This is denoted by the function phi 2. So in that case, f dash z will be, which was ux minus I uy. This it can be write as phi 1 z comma 0 minus I phi 2 z comma 0 f dash z. Now directly integrating this function with respect to z, it will give you fz integration of phi 1 z comma 0 I times phi 2 z comma 0 dz plus constant of integration. So this will give you the result directly in terms of z. This is the Millen-Thomson method. ठीक है? It will be the function of z only. And one more thing I want to tell you here. The Laplace equation in the polar form. Laplace equation in the polar form is written as del square u upon del r square 1 upon r del u by del r. This is del plus 1 upon r square del square u upon del theta square. This is called Laplace equation in polar form. Laplace equation in polar form. Okay, so this was the harmonic function. Okay, one more topic related to it is level curves. Level curves. For suppose that we have analytic function fz, real and imaginary part are u and v. It is an analytic function. It is an analytic function. Then u and v are harmonic function. Are harmonic functions. So the curve curves u x comma y, say that it is c1, and v x comma y c2. c1 c2 are constant. These two are constant. So these two curves is called level curves. They are called level curves. They are called the level curve. For example, if you have a function fz is equal to z, so here it is x comma iy. So u will be x. So u c1 and v c2 is level curve. It means that x is equal to c1 and y is equal to c2. It means that for this analytic function, x is equal to c1. X is equal to c1 will be any line parallel to x is equal to c1. Yes, any line parallel to y axis. X is equal to c1. And y is equal to c2 is any line parallel to y axis. These will be level curve for this analytic function as z is equal to z. And one more important thing is level curves UC1 and VC2, they form an orthogonal family of curves. They form an orthogonal family of curve. Orthogonal family of curve means every member of this curve, family of this curve, must be intersect every member of this family of curve at 90 degree. ठीक है, तो ऑर्थोगोनली कट करते हैं, दैट्स व्हाई दे फॉर्म द ऑर्थोगोनल फैमिली ऑफ कर्व्स. ओके, कुछ इसके और क्वेश्चन होंगे, वो बाद में हम ट्यूटोरियल क्लास में इसको देख लेंगे. हाँ, टॉपिक हम डेफिनेट इंटीग्रल स्टार्ट करना चाहते थे, लेकिन चलिए थोड़ा सा इधर ट्रांसफॉर्मेशन के बारे में बात कर लेते हैं, बिकॉज वी हैव टाइम, सो वी कैन कवर दिस टॉपिक हियर.
हेलो मैम.
यस
मैम, इंटीग्रेशन तो पीडीएफ है कॉम्प्लेक्स नंबर का, मैम उसके पहले वाले पीडीएफ,
उसके पहले वाले पीडीएफ मतलब ये डाले तो हुए हैं. एनालिटिक फंक्शन का तो हमने वो पीपीटी दे दिया है ना, एनालिटिक फंक्शन का.
मैम यहाँ पे क्लास मटेरियल्स में जो हमारे टीम्स का क्लास मटेरियल सेक्शन है,
हाँ,
इसमें
वहाँ पे उसका पीपीटी दिया हुआ है ना,
जो
देखिए
यूनिट,
यहाँ पे
मैम जो यूनिट
वो
4
एनालिटिक
का
फंक्शन तक है. जो पीपीटी शेयर किया है वो एनालिटिक फंक्शन तक टॉपिक कवर है उसके अंदर. यूनिट वाइज उसके अंदर नहीं पढ़ा होगा, देखो अगर अंदर नहीं पढ़ा होगा तो बाहर उसमें क्लास मटेरियल नहीं पढ़ा होगा.
ओके मैम, ठीक है मैम, मैं देख लूँगा.
हाँ, उसको चेक कर. So next topic is linear transformation. Linear transformation, because it is important topic, that's why I don't want to skip it. So a mapping a transformation of this form, mapping a transformation of this form, W is equal to AZ plus B, where this A and B are real or complex constants. They are real or complex constant. So this type of transformation is called linear function or linear transformation or linear mapping. Why it is called the linear? If you will take for suppose that W is equal to Fz. So if we are substituting here in place of this Z, C1Z1 plus C2Z2, it will give you C1 times Fz1 plus C2 times Fz2. अगर इस तरह से हमारा कोई फंक्शन फॉलो करता है, so this is called the linearity property. So this type of transformation follow the linearity property, that's why it is called the linear transformation. Okay, and this linear transformation can also be defined like, for suppose that we can also write it like A into Z plus B by A, where this B by A will be again a real or complex constant, and this A, it may be a complex constant, so in place of this A we can also write as mod of A. If it is a non-zero value, so we can write here mod of A exponential of I phi, where this phi is argument of this A, where this phi is argument of A. Okay, so this map, yeah, this transformation can be considered as composition of three types of mapping. We can see this as composition of three types of mapping. First is we can consider it like W1, consider it like W1 J Z plus B by A. Okay, ये W1 is we can consider it like W1 J plus B by A. It means that W1 can be write as Z plus C, because it is a constant, so we can replace it by a constant C, where C is real or complex constant. Second thing, we can also consider it like W2 K times W1. This is a constant term, so we can see it like k times W1, where this k is modulus of a, which is real and positive constant. K is real and positive constant. Third one is, we can also see it like W as exponential I phi into W2.
मैम
अलग अलग ये क्या है, इनके बारे में हम डिस्कस करते हैं। ये जो हम लिख रहे हैं W1 Z प्लस C, W2 K इंटू W1, W इज E phi, W2, तो ये अलग अलग की हम मैपिंग कहलाती है, उनके बारे में हम डिस्कस करते हैं। या someone is asking?
मैम जो लीनियर ट्रांसफॉर्मेशन है z प्लस b, तो मैम वो सेटिस्फाई तो नहीं कर रही कंडीशन को, f ऑफ c1z1 प्लस c2z2। मैम जो b कॉम्प्लेक्स है, जो कांस्टेंट है, वो प्रॉब्लम करेगा।
हाँ हाँ, ये प्रॉब्लम करेगा। 1 सेकेंड, इस इशू में यहाँ से देखती हूँ। वैसे ये लीनियरिटी के लिए ये लीनियर मैप के नाम से ही जाना जाता है फिलहाल।
ओके मैम।
दिस इज नोन बाय द लीनियर मैप। Okay, so first we will discuss about the map W is equal to Z plus C. मान लीजिए इस तरह का मैप लेते हैं, W is equal to Z plus C. It is called translation mapping. Translation mapping या transformation. Why it is called the translation? For suppose you know that we can write this Z as x plus iy and C may be a real or a complex constant. We can also write it like C1 plus I times C2. We can write this C as C1 plus I times C2, and you know that W will be U plus IV when we are writing it in real and complex form, so it will can be represent as U plus IV. Now substituting this value here, so W is equal to x plus Iy plus C1 plus IC2, so this will be x plus C1 I times y plus C2. So U will be x plus C1, because if we are writing here U plus IV, and comparing both sides, real and imaginary parts, this will give us U is equal to x plus C1 and V is equal to y plus C2. Okay, x plus C1 and y plus C2. So you can see here, if we are talking about Z plane and W plane, so this is Z plane. It is x-axis, y-axis, u-axis, and v-axis, and it is w plane. For suppose that we have a point z, which is x and y here. So correspondingly, this point will be mapped here. This point will be mapped here, where u will be x plus c1 and v is y plus c2. It means that it will be mapped in the point x plus c1 and y plus c2. कैसा होगा ये पॉइंट? x plus c1, मान लीजिए ये x, y था, तो x plus c1 यहाँ पे and y plus c2 will be somewhere here. तो this will be the point. तो ये पॉइंट केवल यहाँ पे हमारा क्या हुआ, ट्रांसलेट हुआ है हॉरिजेंटली इन c1 डायरेक्शन एंड वर्टिकली C2 distance, ये हमारा translate हो गया point under this map. So that's why it is called the translation mapping. Here the point simply translate from its original position to in direction of the vector C, and this vector C is C1 I C2. So it translate in direction of C1 plus IC2. तो इसी तरह अगर हम यहाँ पे कोई फिगर या कोई रीजन भी लेते हैं, that region will be again translate from its original position to in direction of this vector C1 plus IC2. Okay, that's why it is called the translation map. And for suppose that there is the 2 points Z1 and Z2, or suppose that there is a 2 point Z1 and Z2 in Z region, and correspondingly image of that point is W1 and W2 in W plane. So for suppose Z1 and Z2 are 2 points in Z plane, correspondingly image of this Z1 under this map will be W1, which will be Z1 plus C, and W2 will be Z2 plus C. Okay, so distance between W1 and W2 is equal to Z1 plus C minus Z2 minus C. It will be same which was in Z plane. So you can see that distance between the point after coming in W plane, it is preserved और क्या है ये invariant है. So it means that when we are dealing with the translational mapping, so it preserves the distance between two points. Okay. Next is magnification or contraction mapping. This is the mapping of this type Kz, where K is a real and positive constant. K is real and positive constant. This is real and positive constant. It is also known as magnification or contraction. Contraction mapping. For suppose that we are taking this Z in polar form, REI theta के form में. So correspondingly, W will be K times Z. It will be K REI theta, where K is positive. So you can see here the difference is here. Mod of Z is R, mod of W is K times R. So this is K times mod of Z. An argument for W and argument for Z is same, which is theta here. It means that it only magnify or contract the original figure or region in Z plane when we are taking the image of this region under this map. So if K is greater than 0, so we will say that this magnified the this K factor will magnify the region, and if K is less than 1, if this K is greater than 1, it will magnify the region which will map under this this mapping, and if K is less than 1, it will contract the region which is mapped under this mapping. So when K is greater than 0, so mapping is called magnifying, and when K is less than 0, it is called contraction mapping. And when K is equal to 1, so W is equal to Z, it will be identity map. Okay. Next is rotation mapping. For suppose that W is E5Z. E5Z. So this is called rotation mapping. Rotation mapping. It will be called rotation mapping. Okay. And when this phi will be greater than 0, then we will say that the original figure will be rotate in positive direction, yani anti-clockwise direction. And when this phi is less than 0, it means that our original region will be rotate in clockwise direction by the angle phi. So you can see here Z is equal to R EI theta. So W will be R I phi into I theta. So we can write here theta plus phi. So here is only the change. जो figure में केवल change आया है वो है argument का. This is theta and phi. This is the inclination or rotation of the region. तो ये हमारे पास जो if we are mapping, we are taking a point R and theta in Z plane. So under this map, it will be mapped to the point r theta plus phi. तो केवल यहाँ पे क्या होगा, मॉडुलस तो चेंज नहीं हुआ, केवल एंगल यहाँ पे जो है आर्गुमेंट चेंज हो जाएगा इन डब्ल्यू प्लेन. सो अकॉर्डिंगली जो भी फिगर होगा वो हमारा उस तरह से पाई एंगल मूव करेगा. फॉर सपोज जैसे हम मान लीजिए यहाँ पे एक रेक्टेंगल ले लेते हैं, इस तरह से एक रेक्टेंगल ले लेते हैं जेट प्लेन में. तो क्या होगा कि जब हम इस मैप के अंदर आएंगे और फाई इज ग्रेटर देन 0 है, तो दिस विल बी मूव लाइक दिस. साइज में कोई फर्क नहीं पड़ेगा, बट आवर रीजन विल बी मूव टू एंगल फाई. जो भी है इसका एंगल होगा, दिस विल मूव इन एंटी क्लॉकवाइज डायरेक्शन, फाई एंगल पे मूव कर जाएगा. ओके. And your linear map is combination of these three type of mapping. Example देखते हैं यहाँ पे. For suppose that we have a rectangular region. We have a rectangular region ABC. It is a rectangle. Rectangular. This is a rectangular region with vertices. With vertices 0, 0. A is 1, 0. B is 1, 2. C is 0, 2. We define in Z plane. Find the image of this region. Find image of this region in W plane under the map Z plus 2 plus I. Z 2 plus I. देखिए यहाँ पे केवल एक कांस्टेंट आ रहा है 2 plus I. C is 2 plus I. So 0, 0, this will be O. A is 1, 0. B is 1, 2. And C is 0, 2. 0, 2. This is the rectangular region OABC. Under this map, 0, 0 will be translate to the position 2, I. When we are substituting in place of 0, 0, so W will be image of this Z. Image of this 0 under this W will be 2 plus I. 2 plus I means the point 2, 1. So this point O will be transferred to 2, 1. 2, 1. 2 distance and 1. So this will be O dash. Correspondingly, this vertex A, which is 1, 0. So 1, 0 will be translated to 3 plus I. 3 plus 1. 3, 1. So 3, 1. This is 2, 1. Here is 3, 1. This is A dash. So this will be A dash. And correspondingly B will be 3, 3. So this will be 3, 3. 3, 3 will be B dash. And next C is 0, 2. Means 2, 2. So this is 2, 1. So 2, 2. Yes, 2, 2. This will be C dash. 2, 2. So correspondingly rectangle जो होगा हमारा वो केवल इस तरह से फिगर ट्रांसलेट कर जाएगा. Next, one more important mapping is inverse transformation. Inverse transformation. Inverse transformation. A mapping like this, 1 by Z. So this type of mapping is called inverse mapping, or this transformation is called inverse map. and this will be can also be written as z is equal to 1 by w. And this mapping is 1 between non-zero point of z plane to non-zero point of w plane. And this can also be written as w is equal to 1 by z can also be written as z bar upon mod of z square. This can also be written like this. Okay, we have to find the image in w plane of disk, a closed disk z minus 1 less than or equal to 1 under this inverse map, inverse map in the inverse map 1 by z. एक second, 1 second. Okay, so w is equal to 1 by z. We can take w as u plus iv. So this can also be written as z is equal to 1 by w. So we have to find this z minus 1, image of this z minus 1 less than or equal to 1. So z is 1 by w, so z minus 1 will be 1 by w minus 1, which will be w 1 minus w. Okay, mod of z minus 1 less than or equal to 1. This is our reason. Close this about the 1 and radius is also unit. The radius is also 1. So from here we can, in place of this z minus 1, we can substitute 1 minus w upon w. So this will give you 1 minus w upon w less than or equal to 1. Or we can say that 1 minus w is less than or equal to w. You know that we can write this w as u plus iv. So substituting it here. So 1 minus u plus iv less than or equal to u plus iv. Taking both sides the square. So we can write it 1 minus u plus iv whole square is less than or equal to u plus iv whole square. This must be equal to 1 minus u square plus v square less than or equal to u square plus v square. Now solving it, u square minus 2u plus 1 plus v square less than or equal to u square plus v square. Okay, cancelling these two terms. We can write 1 is less than equal to 2u, or we can write u is greater than equal to 1 by 2. So this will be the line u is, this is u and v. So u is greater than or equal to 1. Say that it is u is equal to 1 by 2. So this is the line u is equal to 1 by 2. Reason will be u is greater than or equal to 1. This will be the reason. So this inverse map the unit disk about 1 of radius 1. This is the closed unit disk. Is disk go under the inverse image? It is map here. Under the map w is equal to 1 by z. This is map in this unbounded. It was a bounded region, but under the inverse map it is bounded to unbounded region defined by this. Okay. Next topic is bilinear transformation. Bilinear transformation. This is also known as Mobius transformation and linear fractional transformation. This is also known by this now Mobius is given the mathematician who studies about this transformation. So Mobius transformation. Mobius transformation. Okay, a transformation of this type az plus b and cz by d, where the numerator and denominator both are the linear map. So this type of transformation is called the bilinear transformation, and provided that the condition AD minus BC is not equal to 0. So this type of transformation where A, B, C, D are real complex constant is called bilinear, linear fractional or Mobius transformation. Okay. अब इसमें कुछ points है जो we should know. For this transformation, if denominator is non-zero, if Cz plus D it is not 0, then for every z, for each z we have a unique W. For each z we have a unique W. It means that it is single valued function. Okay. And second is when both C and D is 0. If both C and D both are 0, these two are 0 simultaneously, in that case this function is not defined, then W is not defined. Then W is not defined in finite complex space. Okay. It is not defined for any z in finite complex space. Okay. And this is not defined for all z. Third is if AC 0 or B and D is 0. B and D is 0. Either these two are 0 or these two are 0. So we will get a constant map. You can see here, अगर B और D 0 हो गया, we will get AZ upon CZ, Z cancel हो जाएगा and we will get A by C. So it means that this is a constant map. It will map the whole Z plane into a one point. And then W will be a constant map. Constant for all Z. Okay. And when A and B is 0, A and B is 0, in that case W is 0 for all Z. W is 0 for all Z. So क्या होगा, whole complex plane will be mapped to the origin in W plane. And fifth is if C is 0 and D is not equal to 0. C 0 है but D not 0. So this bilinear map will be reduced to linear map. It will be W AZ plus B D like this. So it will be a linear map. And next is the case is if A is 0, B not equal to 0 and C is also not equal to 0. Is that A is 0, B not 0, C not 0. So B upon CZ plus D. So W will be B upon CZ plus D, which can also be written as BC 1 upon Z plus D by C. So इस map को देखें. So you can see that this map is combination of किस map का combination है ये. 1 by Z लिखा हुआ है. It is the combination of inversion map है. Z plus D plus C, D plus C is a constant, so translation भी है. And B by C लिखा हुआ है, so rotation, क्योंकि ये complex constant है, तो इसका कुछ argument भी होगा और modulus भी होगा. So it is also defining the rotation and magnification. So we can say that in that case, this map is combination of translation, inversion, rotation, and magnification. अच्छा, ये तो हमारे पास finite complex plane में bilinear की बात कर लिया था. Now we will discuss about the same mapping in extended complex plane. मतलब जब Z plane और W plane दोनों में हम infinity को include कर रहे हैं, then so mapping in the extended complex plane. Extended complex plane. Okay, we have a bilinear map AZD upon CZ plus D provided that AD minus BC is not equal to 0. It is our bilinear map. Okay, we can also write it Z in terms of W when we are representing the same map as Z in terms of W. So this must be CZD W AZ plus B. CZW plus DW AZ plus B. This can also be write as Z CW minus A. Okay, CW minus A B minus WD. Z will be B minus WD upon CW minus A. So this is another form of the same map where we are writing this Z in terms of W. Okay, so if C is not equal to 0, for suppose that we have, because हमने बाकी सारे complex points की बात कर ली, now we have to want to find the behavior of this map at Z is equal to infinity and W is equal to infinity. Okay, so when first is if C is not equal to 0, if C is not equal to 0, and for Z is equal to if Z is equal to A by C. Okay, from here. Yeah. For Z is equal to minus D by C. If we are taking Z is equal to minus D by C. So what will happen when we are for this point Z is equal to minus D by C if C is not equal to 0. W is a map, this point D minus C will be mapped under this map to infinity. This will be mapped to, this point will be mapped to W is equal to infinity. And also for equation 2, if we are taking, if in this equation, equation number 2, if we are taking W is equal to A by C, for the same case, if we are taking W is equal to A by C, because C is non-zero in case, so from this equation number 2, this will be, at this point, W will be pre-image of Z is equal to infinity. So Z is equal to infinity की जो pre-image होगी, in that case will be A by C. And when our CZ plus D, CZ plus D is not equal to 0. If this CZ plus D is not equal to 0, so Z is equal to infinity is also mapped to W is equal to infinity. यहाँ से Z is equal to infinity will be mapped to W is equal to infinity. For CZ plus D, for the condition C is 0. For the condition, यहीं पर हम कर ले रहे हैं because we have to come in the back slide. If C is 0, if C is 0 here, then you can see here Z is equal to infinity will be mapped to W is equal to infinity. If the case C is 0, Z is equal to infinity will map to W is equal to infinity in that case. So these are all about the points in extended complex plane. This is how this mapping will behave for the extended complex plane. Next is fixed point of this map. Fixed point of map. Fixed point of a mapping. A point Z is said to be fixed point under a map. For suppose we are considering a map W is equal to Fz, and the point Z is called the fixed point or invariant point of a map if image of this Fz under this map is Z again. It means that W is equal to Z. If for any Z in complex plane, its image under this map F is also again that point itself. So we will say that Z is fixed point. In that case, Z is fixed point or invariant point. Invariant point. For suppose we have a map Fz is equal to Z bar. Fz is equal to Z bar. तो इसके फिक्स पॉइंट क्या होंगे? If it is a we have to find a z for which fz is equal to z. We have to solve this equation. We have to find that z for which fz is equal to z. So this will give you z bar is equal to z, and z bar is equal to z means x plus. If z is x plus iy, it will be x minus iy, and this will be x plus iy. So this is giving you 2y is 0. It means that y is equal to 0. So for the all line y is equal to 0. For the या कहें for all real x. जब हम रियल वैल्यू होगी z की रियल वैल्यू होगी, so जितने भी रियल पॉइंट्स हैं all are the fixed point. All the real points for this map will be यानी कि रियल एक्सेस पर जितने भी पॉइंट्स हैं हमारे all are the fixed point for this map. So this map has infinite number of fixed point. Theorem है. इसको क्रॉस रेशियो भी बोलते हैं, जो रेशियो हम यहाँ पे लिखेंगे कुछ मैप फाइंड करने के लिए इनका हम यूज करते हैं. तो थ्योरम इज द ट्रांसफॉर्मेशन W is equal to Fz, which maps three distinct points, which maps three distinct points in Z plane, Z1, Z2, Z3, in Z plane onto three different points W1, W2, W3 respectively in W plane is always unique, is unique, and it is given by W minus W1, W minus W1, W minus W2 into W3 minus W2, W3 minus W2 and W1 minus W2 is equal to Z minus Z1, Z minus Z2, Z3 minus Z2 and Z3 minus Z1. This can also be written as W minus W1 divided by W1 minus W2. W1 minus W2. सॉरी, यहाँ पे मिस्टेक किया मैंने. ये W3 W1. So this will be W3 minus W1 divided by W minus W2 whole divided by W3 minus W2, or Z minus Z1, Z3 minus Z1, Z minus Z2, Z3 minus Z2. इस फॉर्म में भी लिखा होता है. This is also known as cross ratio. This map is also known as cross ratio. So if Z1, Z2, Z3 are the different points in Z plane, and correspondingly under the same map, its images are W1, W3. These are also the distinct point in W plane. So this map will be unique, and it is given by this. ये map हमारा mapping होता है W1, W2, and if one of these point is infinity, इनमें से जो हमारा कोई भी Z1, Z2, Z3 या W1, W3 जो लिया है, if any one point of this point is infinity, then the ratio of two differences, the ratio of the differences containing this point is replaced by 1. वो कैसे replace करते हैं 1 से, वो हम बाद में बताएंगे कैसे replace करते हैं जब क्वेश्चन कराएंगे क्रॉस रेशियो से रिलेटेड. Yeah. Question is, find the image of region. Find the image of region greater than or equal to 2. Second is y greater than or equal to 1 in Z plane under the mapping W is equal to 4z plus 1, 2 plus z minus 2 minus iota. तो सिंपली यहाँ पे x लिखा है, y लिखा है, तो हमें z को एक्सप्रेस करना होगा इन टर्म्स ऑफ w. देन वी आर राइटिंग z इन टर्म्स ऑफ x plus iy and w as u plus iv. Okay, so let's cross multiplication करते हैं. By cross multiplication we can write here 4z plus 1 wz minus 2w minus iw 4z plus 1 wz minus 4z 1 plus 2w plus iota w, and this z will be 1 plus 2w plus iota w upon w minus 4. This is w minus 4. So z can be write as x plus iy, and 2 w can be write as u plus iv, I u plus iv, and in the denominator we will have u minus 4 plus iv. First of all, we will rationalize this denominator by multiplying u minus 4 minus iv in numerator and also in denominator, and this will give you, इसको solve कर लीजिएगा. So after solving, numerator में कुछ मिलेगा और denominator होगा u minus 4 square plus v square, और there will be something and iota, यहाँ पे कुछ part होगा. तो correspondingly x आपको मिल जाएगा in terms of u and v, and y also you will get the y in terms of u and v. इसको clearly solve कीजिएगा तो यहाँ से आपको मिल जाएगा. And your reason is x is greater than 2, तो ये वैल्यू यहाँ सब्स्टिट्यूट कर देंगे तो then we will get, चलिए कर ही देते हैं, एटलीस्ट एक तो कर ही देते हैं. फॉर सपोज 1 से मल्टीप्लाई हुआ u minus 4 iv 2 times u square minus 8u minus 2i uv. रियल एंड इमेजिनरी पार्ट को मल्टीप्लाई करेंगे, देन वी विल गेट हियर मैं डायरेक्ट आंसर लिख रही हूँ. We will get 2u square plus v square minus 7u plus 4v minus 4 minus 4. This is u plus iota u square plus v square 4u minus 9v. So x will be when we are substituting z is equal to x plus iy, x plus iy. So by comparing it, x will be 2 times u square plus v square minus 7u plus 4v minus 4 divided by u minus 4 plus v square. Our reason is x greater than or equal to 2. So substituting this value of x here, 2u square plus v square 7u plus 4v minus 4 divided by the same. तो डायरेक्टली हम लिख रहे हैं इसको u minus 4 square plus v square. Now solving it, right hand side will give us u square minus 8u plus 16v square. 2u square plus v square. So 2u square cancel, v square is also cancelled, minus 7u plus 4v minus 4. Okay, so we will get 7u plus 4v minus 4 is greater than or equal to minus 16u plus 16. So this will be इसको एक साइड ले जाते हैं, क्या आ रहा था minus 16. ओके, 16u 7u 4v minus 4 minus 16. I think it is minus 16. Yes, greater than or equal to 0. So from here we can write 9u. Yes, 9u plus 4v minus कितना होगा 20 greater than 0. So this is representing a straight line. So it is representing a straight line here. Correct? है ना? So it is representing here a straight line. Similarly, y greater than or equal to 1 के लिए भी reason we can find. Okay. Question is, find the image of closed half disk. Find image of closed half disk z less than or equal to 1 and imaginary part of z is greater than or equal to 0. It means that a unit closed disk about origin of radius 1, but imaginary part is greater than 0, 1. It means that we have this type of semi-closed semi disk जो मिलेगी हमारी यहाँ पर half plane half disk. This will be the reason. This will be the reason it is denoted by here. And we have to find its image under the bilinear transformation wz upon z plus 1. Again we have to write this z in terms of w. So wz plus 1 w plus z. So wz minus z is minus w and z w minus 1 is equal to minus w. So z will be minus w upon w minus 1. So reason z less than or equal to 1. Less than or equal to 1. So this will give you minus w upon w minus 1 is less than or equal to 1. So this will give you w is less than or equal to 1 minus w, या w minus 1 ये भी लिखना है. And this will give you, if w is equal to u plus iv, so this will give you both sides taking the square of both sides. So u square plus v square and less than or equal to 1 minus u square plus v square. Solving it, u square plus v square less than or equal to u square minus 2u plus 1 plus v square. So we will get u is less than or equal to 1 by 2. एक तो ये रीजन मिला, लेकिन साथ में कंस्ट्रेंट है y is greater than or equal to 0. So again we have to solve this, z(w) upon 1 minus w. z1 minus w again हमें solve करना पड़ेगा. So you know that w can be write as u plus iv and this can be write as 1 minus u plus iv. Multiplying in both numerator and denominator by the conjugate of 1 minus u plus iv minus iv 1 minus u minus iv. Simplify कर लें and this will be x plus iy. U minus u square minus iota u into v plus iota v minus uv plus v square divided by 1 minus u square plus v square. So this will give you, ये क्या था हमारा, u minus u square था. Okay, this was the u square. So u minus u square plus v square plus iota v minus uv minus uv 2uv. 1 minus u square plus v square. So now comparing both sides, real and imaginary part. तो हमें y की जरूरत है, तो केवल हम y लिख रहे हैं. y is v minus 2uv divided by 1 minus u square plus v square. Our reason is y is greater than or equal to 0. It means that this quantity is greater than or equal to 0, and this will imply that v is greater than 2uv. This will give you v minus 2uv is greater than or equal to 0. So we will get v1 minus 2u is greater than 0. एक ये मिला, दूसरा इनइक्वालिटी हमें मिला था u is greater than or equal to half. So u is greater than or equal to half. It means that 2u is greater than or equal to 1. It means that 1 minus 2u is less than 0. So this quantity is less than 0, but product is greater than 0. So this implies that, यहाँ से ये imply करेगा, imply that v is also less than 0. So v is also less than 0. तो इसका मतलब हमारे पास कौन सा रीजन आ गया, u is less than or equal to 1 by 2. This is u is equal to 1 by 2. u is less than or equal to 1 by 2, ये रीजन हो गया. और साथ में कंडीशन क्या है, v is less than 0. रिस्ट्रिक्शन हमारा क्या है, product is greater than 0, 1 minus uv is less than 0. Yes. यस दिस शुड बी लेस देन 0, तो हमारा रीजन ये नहीं होना चाहिए, रीजन शुड बी v लेस देन और इक्वल टू 0, v लेस देन और इक्वल टू 0 हमारा रीजन होगा। दिस इज द लाइन v and v less than or equal to 0, ये पोर्शन, so region should be this, region should be this। नोट्स में यहाँ पे एक जगह मिस्टेक है, इसको चेक कर लीजिएगा, ये यही रीजन है, दिस विल बी द रीजन। दिस इज u एक्सेस एंड दिस इज द v एक्सेस, ये हमारा रीजन होगा। और एक और इम्पोर्टेंट क्वेश्चन है इससे रिलेटेड, क्वेश्चन चलो हम बाद में कराते हैं, पहले हम कन्फॉर्मल मैपिंग के बारे में बता देते हैं, फिर ये क्वेश्चन कराते हैं। नेक्स्ट टॉपिक इज कन्फॉर्मल मैपिंग। कन्फॉर्मल मैपिंग क्या होती है? कन्फॉर्मल मैपिंग let w is equal to fz be an analytic function, be an analytic function, and define a mapping, it is define a map, this is a map from a region d in z plane onto a region d star. D star is actually image of this d under this map in w plane. If this map, we said that this mapping w is equal to fz is said to be conformal, if it preserves the angle between two curves, both in magnitude and direction, For suppose we have a jet plane, this is jet plane, this is x-axis and this axis is y-axis, this u and v, this is u and v. Okay, so this is the axis, and for suppose that there is a point z naught, इस z naught से पास करते हुए हमारे पास दो कर्व हैं c1 and c2, both are intersecting at this point z1. This is the curve c1 and this is the curve c2, which is passing through this point z naught in z plane. Angle between this curve is alpha. And direction is this in the positive direction. ये इसका positive direction. If this curve c1, ये curve c1 under this map w is mapped in w plane like this, ये map हुआ. For suppose this is c1 star. c1 star is image of this c1 under this map, and this c2 is mapped, and this point z2 is mapped here in w1, and this is mapped here in c2 star. The c2 under this image is mapped in the c2 star. Now the angle between them is same. This is in magnitude alpha, it is also alpha, and direction is also same. It was the anti-clockwise direction, it is also in the anti-clockwise direction. So we say that this map, which is analytic map from region D to D star, if this map is preserving the angle between these two curves both in magnitude and also in direction, दोनों ही केस में ये जो एंगल है between these two curves is same, both in magnitude and also in the direction, then we will say that this mapping is conformal. Okay, so this is called the conformal map. अब इसकी एक सफिशिएंट कंडीशन होती है कि कब कोई भी मैप एनालिटिक फंक्शन को हम कहते हैं यह कन्फॉर्मल है. सो एट ईच पॉइंट z where fz is analytic, and f dash z is non-zero, the mapping w is equal to fz is conformal. किसी भी पॉइंट पर फंक्शन अगर एनालिटिक है और उस पर उसके डेरिवेटिव की वैल्यू नॉन जीरो हो जाए तो हम कहते हैं कि उस पॉइंट पर मैपिंग जो है हमारी वो कैसी है, कन्फॉर्मल है. और इफ f dash z is zero at that point, so that point is called the critical point. And if f dash z is zero, so z is called critical point of analytic function, point of fz. Okay. Next is isogonal mapping. If an analytic function preserves the angle only in magnitude, not in direction, so that kind of mapping is called isogonal mapping. If it is preserving the magnitude but not necessarily the direction, so that kind of mapping is called the isogonal mapping. For suppose that if we have a mapping z square, you know that this mapping is analytic everywhere in finite complex plane. So we have to find if this mapping is conformal or not. So you have to find its derivative, which will be 2z, and the point where this f dash z vanish, that point will be called the critical point. Their mapping will be not conformal. So equating to this to 0, this will imply that z is equal to 0. So at the origin, this mapping is not conformal. So z is equal to 0 is called critical point. Critical point of fz is equal to z square, and all other places it is a conformal method. On other point, it will map the every z in w conformally. Okay, and one more topic related to it is what will be the angle of rotation at particular point z naught under any mapping, and also its scale factor. So scale factor and angle of rotation at z naught of a mapping w is equal to fz is angle of rotation is defined as phi dash z naught, argument of phi dash z naught. Argument of phi dash z naught. And scale factor will be mod of f dash z naught. This will be the scale factor. Okay. It is all about the conformal mapping. अब कुछ क्वेश्चंस थे इम्पोर्टेंट. एक क्वेश्चन हम आंसर कर देते, बाकी हम ट्यूटोरियल क्लास में एक दो डिस्कस कर लेंगे. ओके. एक सेकेंड. Find all the bilinear transformation whose fixed points are -1 and 1, and एक ही बता देते हैं, बाकी सेम ले लेंगे. minus 1, 1 and minus 1. Okay, so you know that bilinear transformation is defined like this: az upon cz upon d, and साथ में हमारा होता है ad is minus bc is not equal to 0. So this is the bilinear transformation. So fixed point says that w is equal to fz is equal to z. So minus 1 and 1 are the fixed point. It means that f minus 1 is minus 1 and f of 1 is 1. So first off, we are solving for f is equal to 1. So for z is equal to 1, w is also 1. So z a plus b, c plus d. This will give you c plus d is equal to a plus b. Okay, we can also write as c plus d minus a minus b is 0. Say that it is 1. Again, solving it for minus 1. So you know that for z is equal to minus 1, w is also minus 1. So minus 1 minus a plus b minus c plus d. This will be c minus d plus a minus b 0. So solve these two equations 1 and 2. Solving these two equations. In the first case, when we are adding these two equations, d will be cancelled, a will be cancelled. So we will get 2c equal to 2b. This will give you b is equal to c. And again, subtract कर लेंगे when we are using b is equal to c. So we will get also a is equal to d. Substitute कर लीजिए b is equal to c in equation 1. We will get a is equal to b. So now substituting this value here, our bilinear transformation will be w az plus b upon cz plus d. In place of b, we are writing again a, and in place of d, again we are b is equal to c. Sorry, b is equal to c. bz, and this is a. So this map az plus b, bz plus a for all z. This is the map whose fixed points are z1 and minus 1. So this is the bilinear map whose fixed points are 1 and minus 1. So एक ये तरीका हो गया हमारा करने का. एंड एक क्वेश्चन, चलिए टाइम है तो थोड़ा सा एक क्वेश्चन और डिस्कस कर लेते हैं. Find the bilinear transformation. Find the bilinear transformation. BT, bilinear transformation, which maps the point z is equal to I 1 2 plus I in z plane. These are 3 points in z plane onto w is equal to 1 I and infinity in w plane. तो एक तो हम क्रॉस रेशियो से कर सकते हैं, दूसरा इसी तरह से a z plus d plus upon c z plus d कर सकते हैं. So this is given that z is equal to I is mapped to 1 and 1 is mapped to I and 2 plus I is mapped to infinity. We have the map in general cz plus d. This is the map.